Here are some review questions for Chapter 9. This follows the review that we have on big ideas, all right? So questions might look a little different because they're in print format, but these are the questions. So the first one here, we got a Pythagorean Theorem question. So good little warm-up. A squared plus b squared equals c squared, nothing too big. And so 7 squared plus x squared equals 13 squared. And when we subtract from both sides, we get 120. When we square root, we get x equals the square root of 120. Now this question says the nearest tenth, so we're going to go ahead and use our calculator for this. And we square roots, and we get 10. It's 10.95. Okay, and when we round that to the nearest, we're going to cut it off here. That 9 has to go up to a 0, so it's going to become 11.0. So the answer is 11. And is that a Pythagorean triple? Well, it's actually no, so it's not. All right. Now let's change the question real quickly here to review. It's exactly the square root of 20, so we're going to need to simplify that and be ready to simplify that. And so the square root of 120 is the square root of 3 times the square root of 40. Wait a minute. Let's make that the square root of 4 times the square root of 30. There we go. That's what we want. And that becomes 2 square root of 30. So we've got to remember how to simplify radicals. Okay? Now, the answer here is 11. But be ready to simplify that for a test. Okay? 2. All right? We want to find the value of x. Now, this is a special right triangle. You could use the Pythagorean theorem. We could go 6 squared plus 6 squared equals x squared. And this is going to give you the square root of 72. But because these are the same, this has to be a 45, 45, 90. And we have a rule. And the rule that we've learned is that when it's a 45, 45, 90, we multiply the leg by the square root of 2. And this gives us 6 times the square root of 2. So we call it 6 square root of 2. Okay. And that is simplest form or simplest radical form. All right. No decimals. It's exact. All right. So this means about 6 times 1.414. You know, you can get a decimal value for square 72, but this is the exact. All right. Question 3 here. Find the value of x. This is another special right triangle. So we have the 45, 45, 90. Let's review that real quick. The 45, 45, 90. Okay, so that's half of a square. So when we have a triangle that's 45, 45, 90, we know the two legs are the same because it's half of a square. So we'll call this A and A. In other words, they're both the same length. And then the hypotenuse is A times the square root of 2. So if we're going this way, we multiply by the square root of 2. If we know the hypotenuse and we're going backwards, we divide by the square root of 2. Okay? And then we have another special right triangle, and that is this 30, 60, 90. Okay, there we go. And so if this is a right triangle, and we know this is 60, well, the other one has to be 30. So in this 30, 60, 90 triangle, it's all about the short leg, okay? So if the short leg is 8 units long, then the hypotenuse is going to be twice as long because this is half of an equilateral triangle. Let's go like this, all right? So this is half an equilateral triangle that has sides of 2a, all right? And if we want to find the the long leg, we take a times the square root of 3. So that's the sides of the 30, 60, 90. The sides of the 45, 45, 90 are 2 legs of a, and the hypotenuse is a times the square root of 2. So those 2 little pictures are kind of ones to memorize, all right? So in this case, there's a 30, 60, 90. And so we can remember this is half of, imagine this is half of an equilateral triangle. That can help, okay? And we know that the short leg and the hypotenuse have a relationship of 2. The hypotenuse is 2 times bigger. So if we're going backwards, we're going to divide by 2. So we're going to divide by 2. 14 divided by 2 is 7. So the missing side is 7. All right. Okay, here we have a short leg. So the short leg, now the short leg has a square root of 3 in it in this. Okay, don't get confused. The square root of 3 is just a number. 8 times the square root of 3, punch in your calculator, it's about 8 times 1.7. I don't know, it's going to be close to 14 or 15 there. But that's the short leg, and so we're going to go times 2. So we should be thinking about this picture that we just drew up above. Okay, I'll draw it sideways since this triangle's a little different. It's kind of fallen over. So if this is a, then the hypotenuse is 2 times a, and the long leg is a times the square root of 3. Okay, so here we take 8 square root of 3, which is the number, which is the length, and we're going to multiply it times 2. When you multiply it times 2, we get 16 square root of 3. Okay, and so x is 16 square root of 3. Now we weren't asked for this side, but let's go ahead and do that for practice. Well, 8 square root of 3 is how long the short leg is, so let's multiply that by the square root of 3. And we get the square root of 3 times the square root of 3 is the square root of 9, which is 3. All right? So that is 24. So you've got to be ready for both of those there. Okay? All right. Going backwards here. Let's practice this. If we wanted to find this leg, this would be 7 times the square root of 3. That would be how long this is, 7 square root of 3. All right. Weren't asked for that, but be ready for either of those on the test. All right. So we want to find the tangents of these now. Moving into some trigonometry. We know tangent of an angle is opposite leg over the adjacent leg. So if we want tangent of J, the opposite is 11, and the adjacent leg is 60. Now, 61 is the hypotenuse. It is not the adjacent. So don't get those confused. So tangent, we're just talking about legs here. So this is opposite over adjacent. Okay, now if we start from 60 here, let's erase that. Starting from L, the opposite now is 60. So opposite over adjacent, 60 over 11. Adjacent is 11. All right, so that's how we find the tangent from if we know the sides of the angles. Number 6 here, we're finding some tangents. So tangent of A, opposite over adjacent. So the opposite is 7. The adjacent is 4 square root of 2. Now, we're going to have to go a little bit further here. We need this in simplest radical form. So we have 7 over 4 square root of 2. We don't want to leave a radical in the denominator. We have to simplify this. So we need to multiply the top and the bottom by the denominator. Well, you can actually multiply it by 4 square root of 2, or we just need to multiply it by the square root of 2. Okay? The square root of 2 is the square root we need to get rid of. So on top we have 7 times the square root of 2. And on the bottom we have 4 times, and the square root of 2 times the square root of 2 is 2. So that's 4 times 2. So that comes out to be 7 square root of 2 all over 8. Okay, let me write that down here. So this is going to be 7 square root of 2, 7 square root of 2 over 8. All right, so got to simplify that. Now, if we start at B, we got the opposite, which is 4 square root of 2, over the adjacent leg, which is 7. Again, 9 is the hypotenuse. 9 is not an opposite or adjacent, because we're talking legs. Tangent only has to do with the legs. All right, so there you have it there. Okay, I got to simplify it. Always simplify it to get rid of the square root in the denominator. So next we got to find missing sides using sine, cosine, or tangent. We want to find this x. This is opposite to the angle that we know. And this would be adjacent. So we're going to keep using that tangent. Remember SOHCAHTOA. So we decide, first of all, do we want to use sine, cosine, or tangent? SOHCAHTOA is a nice way to remember. And so we have sine opposite over hypotenuse. That's not going to help us because we don't care about the hypotenuse. Cosine adjacent over hypotenuse. We don't care about the hypotenuse and we don't know the hypotenuse. So we want tangent because tangent is involving opposite leg and adjacent leg. So we say tangent of our angle, 54, is the opposite leg over the adjacent leg. So that is a true statement, true equation now. We want to solve it now. We can think of it as a proportion if you want, or just got to get rid of this denominator. So we multiply by the denominator on both sides. And now we go to our calculator, and we want 32 tangent of 54. So let's go down here. 32 tangent of 54. Make sure you're in degrees. If you're using Desmos scientific calculator, it goes to degrees already here. This little switch right here is degrees and radians. If you're using Desmos, the regular Desmos, the graphing calculator, then you have to actually go into the settings, the tool settings, and change it to degrees. So make sure in degrees. And so I already forgot what we have. We have 32 tan 54. 32 times the tangent of 54. Just type it all at once, and you'll get it right away there. We have 44.044, all right? So that is our answer. So x is 44.044. What were we asked to round to? Nearest tenth. Nearest tenth is this first decimal place, so it's 44.0. All right, 44.0. Okay. All right. Moving on. Number 8. Number 8 here, again, another tangent one. So we've got the opposite and we've got the adjacent. We're looking for the adjacent, so that's going to be tangent. So the tangent of 38 is 10 over x. Now we've learned that the tangent of 38 degrees is just a decimal. If you want to go rewrite this decimal right now, you can, and that's fine. But if we make this a proportion, we can leave that actually as tangent 38. Just remember it's a decimal. And let's cross multiply. 2 ways to go here, all right? I'm going to write out kind of the long form and then remind you of the shortcut. If we cross multiply, we get x times the tangent of 38 equals 1 times 10. And then we've got to solve it for x. So we've got to get rid of that tan 38. So let's divide by tan 38, which is just a decimal. And we see that x is equal to 10 over tan 38. And remember, notice here, this proportion here, just these things swap diagonally. So you're welcome to just, once you see that proportion, swap this so that the x is on top and go right down to here. That's fine. So we have 10 divided by tan, 38. Punch that in your calculator, and we get 12.799. So that's 12.799. Directions asked for nearest tenth, which is 1 decimal place here. So that's 12.8. No units there. How about a tree? You want to find the height of the tree here. We're looking up a tree. It's 75 degrees. How tall is the tree to the nearest foot? Okay, well, that just makes a triangle there. And that's a tangent triangle, right? So the tangent of 75 is x over 4. Multiply both sides by 4. 4 tangent 75 equals x. And just punch that in your calculator and we get 3.732. All right. So 3.732. Now always stop and think about your answer. Is this tree 3 feet tall, 3.7 feet tall? It could be, but I think I messed something up. That's a very short tree, like a bonsai tree. So I missed the 4, I think, right? So let's see here. Yep, that's what happened. So let's put the 4 in there. There we go. We got a 14.928 tree. All right, that sounds better. So we got 14.928. What were the directions to the nearest foot? So the tree is about 15 feet tall. Okay, 15 feet tall. That's the idea. All right, so tangent, got that down pretty well. Now we're looking at for some sine and cosine. Remember SOHCAHTOA again. Sine of an angle is opposite over hypotenuse. And cosine of an angle is adjacent over hypotenuse. All right, so the sine is going to be 3 over 5, sine of x now, opposite over hypotenuse. And the sine of z, the opposite of z, is 4. So this is going to be 4 over 5. Now if we're talking cosine, cosine of x, the adjacent is 4. And the hypotenuse is 5. Cosine of z, the adjacent leg is 3. And the hypotenuse is still 5. That's the idea. Another one here. All right. A little overkill maybe. We do have to simplify. I'm betting here. So starting from x, we have 55 over 33 for the sine. 73, that is. And I wonder if that simplifies. Does 11 go into it? No. This is 11 times 55. 11 times 5, sorry. Does 5 go into it? No. Does 11 go into 73? No, because 11 times 7. So actually, we're done. There's no simplifying there. So they kind of tricked us with that directions. 55 over 73. So starting at 7 now, the sine opposite over hypotenuse could be 48 over 73. Again, we got to check here. Factor is 48. This is 16 times 3. Does 3 go into 73? No, it doesn't. 2 and 4, all that doesn't go into 73. So, nope, that's it. Now, the cosine of x, cosine, the adjacent to x, is 48. So, that's 48 over 73. And the cosine of z the adjacent leg is 55, and the hypotenuse is 73 there, all right? So you get 55 over 73. Right now, let's use sine or cosine. And so, starting with 23 here. So, on our quiz, a lot of us went ahead and found this other angle. You can, that's a good option, but you don't necessarily need to. And so, we know the sine of 23 is opposite over hypotenuse, which is t over 34. Okay. Sine is opposite over hypotenuse. We can solve this by multiplying both sides by 34. And we get 34 times the sine of 23, sorry. And so 34 sine 23. There we are. 34 sine 23 gives us 13.28. And I believe the directions ask us to round the nearest tenth, right? Yep. So 13.3. Right, and then next we have T, so S, I'm sorry. S is the adjacent to the 23. All right, so it's the adjacent leg, so that's going to be cosine. Cosine is adjacent over hypotenuse. So the cosine of that 23 is S over 24. Multiply both sides by 24. S is going to be 24 times the cosine of 23 degrees. 24 cosine 23. And we've got 9.4 if we round the nearest tenth. So that's 9.4 is S. So 9.4 for S and 13.3 for T. Great. There you have it. Number 13, a little more of the same. We're going to know that the sine of 36 is going to be S over 5. The cosine of 36 is going to be R over 5. For both of these equations, we're going to want to multiply both sides by 5. And we'll get 5 sine 36. Multiply both sides by 5 here. And you get 5 times the cosine of 36. 5 sine 36 gives us 2.9. 5 cosine 36 gives us 4.0 for R. Okay. Great. And one more. Yes, I agree. This is a little overkill, but they should be super fast. We have sine of 70 equals V over 10. And cosine of 70, cosine of the angle, is W over 10. All right, multiply both sides by 10 here. And we're going to get 10 times sine of 70 is 9.4. And 10 times the cosine of 70 gives us 3.4. And we could look back at the drawing. That seems reasonable. All right, moving on to a different type of problem here now. If we know the cosine of an angle is 0.32, then we want to find what the angle is. So if cosine of Q is 0.32, we've got to flip this in reverse. To find Q, we've got to do the inverse cosine. Kind of like reversing the situation here. So the inverse cosine of 32, and go to your calculator with that. And to find our inverse cosine, we have to go, in this case, to the functions. Inverse cosine, and go back to main, 32. No, 0.32, sorry. So remember, we're entering the ratio, which could be a fraction. It could be, in this case, a decimal. And we'll get that. Now, if we just did 32, you might have saw it said undefined, because you can't actually, a cosine will never be 32. Cosine's always going to be a decimal number. So, all right, so we get 71.3 degrees, and I think it says to the nearest tenth, yep, 71.3 degrees. Oh, I put that in the wrong spot. Oh man, that's number 15. So number 16, same idea, but this is tangent of Q. So we know that the tangent of Q is 0.04 is what that is. And so we need to rewrite the equation. So to find the angle, we use the inverse. Inverse finds the angle. That's the key. So Q, the angle, is the inverse tangent of 0.04. So let's go find the inverse tangent of 0.04. And so we got to go to the functions again, inverse tangent of 0.04. Let's get it inside. .29, or rounds up to 2.3. All right. So Q is approximately 2.3 degrees. All right, so very small angle, very small tangent. Now the last thing we need to do is we need to solve these right triangles, which just means find all the missing sides and missing angles. First thing we want to look for is angle A. Well, this is the adjacent, and so we're thinking about SOHCAHTOA. And so we've got adjacent, so we need the cosine to start with here. And so the cosine of A is 10 over 15, the adjacent over the hypotenuse. And so we can find A by doing the inverse cosine of 10/15, and that gives us A of 48.2, it looks like. All right, 48.2. So we have A. Now you got to find B. So we could just subtract from 180, but let's see that it's actually pretty quick just to go to find B. Now that's the opposite, so the sine of B is the opposite, which is 10 over 15. So B is the inverse sine of 10/15. All right, and which is going to be 90 minus 48, but let's go ahead and just find that. And so sine of B is 10 over 15, convert it to inverse sine. Use our calculator here. And the inverse sine of 10/15 gives us 41.8, and that's what we expect. B is about 41.8 degrees. And if you add those, you get 90, which is what we're going for. Great, we found those. Last thing we need to find is BC. We can use the Pythagorean Theorem for that. We know 10 squared plus x squared equals 15 squared. And so this is just pretty straightforward problem. Subtract 100 from both sides and square root. Square root of 125 comes out to be about 11.2. All right, we're not going to simplify this. We want the nearest tenth. So there it is. So BC is 11.2. All right. So there we had two sides, and we found all the rest. Here's a different triangle. We know two parts, but in this case, what we know is we know the leg, and that's the adjacent leg because it's connected to the 37. So let's use tangent, and we know tangent of the opposite side, which is tangent of the angle, sorry, is the opposite side ML over 6. And so if you multiply 6 times the tangent of 37, we're going to get ML. And 6 tan 37 in the calculator is going to give us 4.5. All right. and that's approximately ml. So this is 4.5. And then we need a hypotenuse. And so you could use sine and use the 4.5 over the hypotenuse. But you want to avoid using that 4.5 because that's rounded. So let's use the 6. So let's use cosine. So cosine of 37 is adjacent over hypotenuse. Well, the adjacent is 6. The hypotenuse is NL. So I use NL. Now, we want to solve this. So remember, when we want to solve this, we want to make it into a proportion and cross multiply. It looks like I lost a 7 in there somewhere. So 37 degrees. I want to cross multiply. But remember, as we saw a few minutes ago, we can just swap diagonally. So NL is just going to be 6 divided by cosine of 37. And 6 divided by cosine 37 gives us 7.5. And then we have to ask ourselves, does that sound reasonable? And I think it does. So this is 7.5. It's in the right ballpark. It's very similar to the other ones. And last but not least, we need to know this angle here. Well, these two add up to 180, 37, 90 actually, sorry. The acute angles add up to 90. And so in angle L is going to be 90 minus 37. And so that's going to give us 53. All right. And we got 4.5 for ML and 7.5 for NL. Great. That's how we solve the triangles. Last one here, very similar. Want to solve the triangles. We can find, so this one a little differently. We got the sine of x is 18 over 25. We're looking for an angle, so we're going to change that to an inverse sine of 18/25. And when you go plug that into your calculator, we get 46.1 degrees there. So since that guy's 46.1, we can just subtract that from 90, and we get, let's see, 44, but it's actually going to be 43.9 because of the 0.1. And then to find this missing side, we need to use the Pythagorean Theorem. So we know xy, we'll just use that as the length of the side, xy squared plus 18 squared equals 25 squared. So to find xy, hopefully with our experience, we see, well, we're going to subtract both sides by 18 squared, whatever that is, and then to get rid of that squared, we've got to square root both sides. So I'm going to kind of jump down the road here a bit, and then we can jump right to the calculator. And with our experience, we can say, I know this is going to be 25 squared minus, was it 18 or 16? It's 18 squared. Okay, make sure that's all under the square root. And so square root of 25 squared minus 18 squared is going to be 17.3. And there you go. We have solved the triangle. We found everything out about the triangle. All right. So we'll leave it at that. That's how we use our trigonometry and a little bit of special right triangles to find missing sides and missing angles in those triangles. We have mastered the triangle. All right. Keep studying, and you're going to do great on the test. So have a great day.